Okay, Christian, so this is the lecture for Theory of Machines, Mech 343. Keep in mind that you love this subject. When you studied hard, when you worked on topics, when you worked on problems, you were fascinated by the fact that you could resolve these types of problems. Keep this in mind when you're studying now. Remember that this is your passion. You're passionate about engineering, and when you got into engineering, why you signed up, why you went to classes for this, why you went to university for this, it was because you were fascinated by this stuff in particular. You love it. Just put in the work, put in the effort, and you'll realize that it's rewarding. You adore this stuff. And remember also, well, you need to pass this class because you want to marry Blanca. Once you are out of university, you can get married to her because you'll be able to have a job and have a life and provide for your family with her. And so you have to keep studying this, and you love this subject. This is why you got into engineering. This is the topics that were most fascinating to you. This class is divided in a couple sections. So chapters 1 through 4 are essentially breaking down the real problems that you're going to be facing in theory of machines. So chapter 1 is step 1 of the problems. Chapter 2 and 3 are the later steps of the problem. And chapter 4 is step 2 of the problem. Okay? Then chapters 5, 6, and 7 is when you pool together these chapters and then a little more on top. And those are the real problems that you're going to be finding on your midterms and finals for this class. This is where the core of the class is learned. Chapters 12 and 13 revolve around gears. These are the ones that you're most successful at. You enjoyed these chapters and you were able to study them well and you enjoyed them. We're going to not only make you be good, we're going to make sure that you are going to be great. You're going to ace these and you're going to have no stress, no worries one bit when you're going to be facing these types of problems. You already like them the most, and so we're going to make sure that you do them even better than how you did last time. Chapter 14, we didn't actually work on it in the class. It was one that ended up getting cut. We're going to study it just because might as well ace everything, might as well be prepared everywhere. So this is new to me. It's going to be new to you. And we're going to make sure that we ace all of the chapters intended for this class. Chapters 16 and 17, that's where you struggled the most. You struggled also on chapters 5 through 7, but you could solve some of it. You really had a harder time with 16, 17. They're late in the class when you learn them. They're complex. They're difficult to resolve. Keep that in mind and set enough time aside to study and be ready for those chapters in particular. Okay, so chapter 1 is the step 1 of solving the problems, the chapters 5, 6, and 7 problems. Step 1, that's it. This is how easy chapter 1 is. Chapter 1 is really, it can be summed to how to solve a mobility of mechanism equation or formula. What are you looking for? You're looking for M. You're looking for mobility. How much mobility does this mechanism you're studying have? Okay? And to find that, you need the number of links, the number of lower pairs, and the number of higher pairs. Okay? What are these terms? Links, you know this. This is easy, links, right? Links is just the components that make the mechanism be what it is, right? It's the structure. Each part connected to each other that creates the predictable motion of a mechanism that you're building. You have to keep in mind that there's a hidden link, a link that is harder to keep in mind. You're going to remember it perfectly because you're never going to have any trouble with this step. This is step 1 of most of your problems. The hidden link is the ground, right? It's a link. It's part of your mechanism. Your mechanism can't operate if it's not tethered to something, if it's not fixed somewhere. or else it's just going to be a string of parts that are going to end up laying flat on the table. You need it linked to the ground. So link 1 is the ground, always. Then you're going to count all your other links, the components, the bars, the gears, the rollers, all of those sliders. Those are each one of those items you'll see in the problems are additional links. Now, lower pairs and higher pairs. What are these? Lower pairs is the more straightforward one. It's just a connection between two bars, right? Well, not two bars always, okay? It's just a connection between two links, we'll call them. It's a connection that restricts a lot of the motion. It means you only have 1 degree of freedom, which allows motion. When you look at a 2 links connected at 1 point, you only have 1 motion between those 2 links. They can revolve around each other. When you keep one fixed, the other one rotates around the other at that point, and then if you keep fixed the other one, it rotates around the same point. There's only rotation motion permitted when you have a point contact, right? You can also have line contact. That's what's found in a roller bearing. Line contact means that there's only one little line that you can follow. You can imagine that line, and it's a track, and it keeps that motion predictable. It keeps it constrained to just that one line. In a roller bearing, the tracks are preventing the balls from going anywhere else but around that line of motion, and it allows it to rotate. It allows the piece to rotate. Higher pairs are looser contact, okay? It's where there is some restriction, but significantly less. Think about a cam and follower scenario. The cam is the circle, well, the oval pear shape, which rotates, and the follower lays on the surface of the cam. And how is it 2 degrees of freedom? It's 2 degrees of freedom because it can slide against the surface of your cam, right? It slides on that surface. But it also has that vertical motion component because the cam is not a flat piece. It's not a perfect circle. It has some, when it rotates, it's going to cause the follower to go up and down and slide on the surface. There's 2 degrees of motion there. It has sliding and it has vertical motion. These are examples of 2 degrees of freedom connection points, but you'll see a lot more, and you'll have to learn to identify them, and we're going to be doing that in the practice problems, okay? The next part of the chapter 1 revolves around the 4-bar mechanisms. So this is more just definitions. It's less crucial to solving these problems. It's for you to know how the terminology is, and when you're faced with a 4-bar mechanism, if you are asked to figure out how the motion works, okay, what's going to truly be happening when this mechanism is in motion, okay? For 4-bar mechanisms, you have crank and rocker, double crank or double rocker. Crank and rocker means one of the links, the shorter link, revolves, rotates, and the longer one will oscillate. So what does that mean? You have the short bar, which has a connecting bar between it and the long bar. And so as the short bar rotates, the motion of it is being transmitted through that long bar, that intermediate bar, to the long bar. The long bar is going to have a rocking motion. It's going to move one side and to the next as the crank rotates. Think about a piston. That's how pistons work, right? It rocks, if you want, up and down as the first bar, the short bar, rotates. Double crank is where both of the links are going to be revolving. Okay, easy enough. The motion from the connecting bar, it's connecting the rotating motion from one to the next. Then double rocker is when the connecting bar is transmitting the rocking motion from one to the next. To figure out what type of motion you're going to have, you're going to use Grashoff's law, okay? And it's an inequality, and depending on how the summations look and come out to be, you're going to see that it's going to have either one rotating link, or it's going to have no rotating links, or it can be laid flat. What do you mean by laid flat? It just means that it has a locking point. It's a point where the mechanism can stop moving. Once it reaches this point, it locks. It blocks itself because of its orientation. And when all of the links are collinear, they all lie on in the same plane, the motion is no longer able to be transmitted. There's no more motion, and it's just blocked. This is usually undesirable, but in some scenarios you want to. Usually, when you're in mechanical engineering, you're not really looking for this for the most part. This is what you learn in Chapter 1. But really, the important thing to master is the mobility of mechanisms, and we're going to do that by doing plenty of practice.
So now we're going to be doing some of the practice problems for Chapter 1, where we learned about the degrees of freedom, right? This is the most important section, okay? These are your goals. Keep them at the forefront of your mind. This is your most important goal. This is another very important goal. You want to achieve these, and they're both achievable in a very, very short term. You want to get married. You know you want to. You want to be an engineer. You love the work. You always love the feeling of knowing you can solve these problems. Remember that feeling of excitement when you resolved it and you got the correct answer. Keep that feeling in mind. Engineering is your passion. Keep that in mind. Read through this. Always go back and look at these. Those are your goals. You have to keep them at the forefront of your mind after solving and before solving every problem. So these are some of the examples that we're going to look at. And so we're going to start with the first one. You have to start off with the formula. You have this formula for mobility. You keep in mind what N, J1, and J2 is. They're marked here. Number of links, number of lower pairs, number of higher pairs. Okay? So how are you going to find your number of links? Well, you know that the ground is always one link. There it is. You know, and then you can just find the components of the mechanism that are more obvious. So there's a block here, there's a block there, and then there's this triangle. Those are 3 links, and the ground is our 4th link. There you go. It's a 4 links. Now the joints. How do you find the joints? The joints are where 2 links meet. So this surface on which B slides on top of link 1, that is a pair. Then you have a second one at this dot. And then same thing here. It's the same types of pairs. How do you determine if they're lower or higher? Well, the first is, let's start with the dot, where the triangle 3, and link 3, and link 2 meet. The only motion allowed there is rotation. There is no other motion it can do. It can't go vertical, it can't go to side, just rotation at that point. So it's a lower pair. There's only 1 degree of motion. On this sliding surface, there's only 1 degree of motion as well. Why? Because it can only slide side to side. It can't slide vertically, and it cannot rotate. So there's only 1 type of motion, and so it's a lower pair. So when you plug these values into your formula, you know that there's 4 lower pairs, 4 links, and 0 higher pairs, and you get a mobility of 1. Here you have a lot more links. You have 6 links and 7 pairs, but you still find at the end that you have a mobility of 1. You can see you plug in, you have to identify all of these links, all of the links you have to identify all of the joints where these links meet, and then you can put this information into the formula. Is there any higher pairs that are obvious? No, there are no higher pairs. Just because it's sliding does not mean it's a higher pair, because the rotation is done at this point between the link and the block, and then the sliding happens between the surface and the block. So there is no higher pair that allows two types of motion. So they're all lower pairs. Here you see your first higher pair. Okay, so where is your higher pair? You have the three links. It's this bar, this circle, and then the ground. Those are your three links. And then your pairs are, well, you have your first pair is between the ground and the circle, the ground and the bar, and then there's a third link, there's a third joint rather, between the bar and the circle. And this is where your higher pair occurs. Why is it a higher pair? Because between these two bars, there is more motion allowed. There is slip and roll motion that can occur right there. And so since there is two types of motion available to at this link, at this joint, then it's a higher pair. And so you can enter this information here, put it into your formula, and it turns out that it also has a mobility of 1. Here, you're back to a mechanism with no higher pairs, okay? You can solve these on your own. I'll let you look at them, but we're going to pass through them quickly. These are some of the more simple ones. Here, why would this not be a higher pair? Because the rotation happens at this point, and the sliding happens between the surface and the slider. So the two motions are separated between two links, between two pairs or two joints. So those are both lower pair. And so that's why there is 4 lower pairs and no higher pair. That distinction will come into play here. You see here the crank, that's this bar here that allows the rotation. It's both rotating here against the surface, this inner oval shaped surface, and it has sliding. It both slides on the surface and it rolls on the surface. So there is 2 types of motion. That's why it's different from this. Even though it looks similar, it's this T-shaped bar, and the slider, since the slider is not part of the same as the link B, it's not the same piece, it's 2 pieces, C and B, so that's why it is 2 lower pairs, whereas here it's 1 piece, so it's 1 higher pair, the connection here. And so you have only 3 parts instead of 4. You're missing the slider compared to the last problem. And so now you can enter this data here. This is the difference. Here you have another slider in here, so it's back to a lower pair. And that's the difference here. This one, this is a little more complex. This is probably the hardest one on the of these examples. How many links do you have? You have 4. You have this circle, you have this bar, you have this slider here, and then you have the surface, the ground. And so between the bar and the ground, there's a connection. Between the circle and the ground, there's a connection. Between the slider and the ground, there's a connection. All of those connections with the ground are lower pair. You see lower pair, lower pair, lower pair. Now here, it is actually a higher pair, right? Because again, think it has some slip and some rolling motion here. 2 types of motion allowed, therefore it's higher pair. And that happens here too, because think about it, as this rotates, this bar will be sliding in and out of this little cutout at the end of the bar. And as it slides, it'll allow the block to slide up and down this wall. But when it slides, it's not only going to be sliding along this hole, but it will be also rotating around the point where these 2 links meet. So that is also a higher pair. That's why there are 2 higher pairs and there's 3 lower pairs. And then you find that the mobility is back to 1 as well. This will not always be the case. In all of these problems shown in this example, they are all mobility of 1, but it will not always be the case. It doesn't really matter the final result. Really, the real trick is to figure out, is it a lower or higher pair? Is that connection going to have 2 types of motion or more, or is it going to only allow for 1 type of motion? That's the real part of this chapter that you need to work to identify clearly. Here, you have rolling motion between these 2 pieces. It's all lower pairs because you said assume rolling contact. Why would you need to know this? Well, because there's the possibility that these could also have slid, but since it's rolling, and since it's clearly stated here, then it's only a lower pair because there is only rolling. There is no sliding. These are pretty much all of the problems here, okay? And you can look through them all again, pause and try and practice and see if you can identify the different types of joints. And there you go. And now, this is why you're working on this. This is why you want to study. Good luck, Christian. You can do it.